Questions on 145? What do we see? What we see? What we see?
I got it right. I got it right.
Anything on page 145? A few of you don't have your books out yet. Please get your books out. 14, thank you. All right, problem number 14. All right, so a couple things I want to see. Is this bottom a perfect square? Meaning, could I take the square root of 4 and get a whole number? Yeah, what's the square root of 4? 2. So watch what happens. The square root stays on top. The bottom just becomes 2 because I could take the square root. What else would you like to work on? 8. You got it. Oh, thank you very much. Cool, thanks. All right, problem number 8. I hear phones that are dinging and they're not mine. And they're not over my right shoulder. All right, so this particular problem we want to distribute, yes? So I'm going to multiply this over the top. So the outsides are going to multiply. The inside stays the same. If I multiply it here, there's a 1 out front. So the outside stays as 4. The inside turns to 45. Okay? So can I break square root of 3 down? It's not going to break down. Does 45 break down? If so, what does 45 break down to? 5 and 9, where 9 is the biggest perfect square. All right, so what's the square root of 9? 3. So there's already a 4 out there. Now it's going to be joined by a 3. Then just clean it up. And that's what it is. Okay? What else do we see? What else can I help you with? 5? Okay. Problem number 5. Oops. All right. Hey, I have a quick question. How do I generate my perfect squares if I don't have them listed? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 7 times 7. 8 times 8. 9 times 9. 10 times 10. 11 times 11. 12 times 12. Agree? Which number on that list of perfect squares do I not really pay attention to?
1.
I don't pay attention to the 1. Very good. Okay, so I don't pay attention to that. All right, so let's take care of the 12 first. 12 falls here. So what times what gives me 12 where one of the numbers is a perfect square? 4 and 3. Good. 4 is a perfect square. All right. Shh. All right, so then I have 4. 27 falls here. Which numbers can I multiply together to get 27 where one of them is a perfect square? 9 and 3. Good. And then minus 48 falls right here. So what is my biggest perfect square that works with 48? Good. 16 works. 16 times 3. Okay, a lot of you might say, well, 4 works as well. You're absolutely right, but 4 is not the biggest perfect square. All right, so let's go through and clean things up. All right, so this first one is going to give me 2 square root 3. Second one, the 4 is already out there. The 9 is a perfect square. Square root of 9 is 3. Minus 2 is still out there. The 16 is a perfect square, so square root of 16 is 4. Clean it up. So we get that. All my radicals are the same. So we can add and subtract. So 2 plus 12 is 14. 14 minus 8 is 6. The root 3 comes along for the right. It doesn't change. That's a good one. Any other problems you would like to take a look at? How much? 13?
Yeah.
Got it. Number 13. 13 looks like it could be totally complex. But what's special about 36? 6, yeah. What's the square root of 49? Yeah, and there's no longer a square root. They were both perfect squares. $11, you got it. All right. So, square root of 144 is 12. Is x to the 6th a perfect square? It's an even number, so it's a perfect square. So how many times does 2 go into 6? Okay. Shh. Is 81 a perfect square? Yep. What should I do with y to the 3rd to make part of it a perfect square? Bring it up to this. So if I had this, square root of y squared, 2 goes into 2 once, so I get y, and then I have this left behind. Okay, so we have to clean some things up first. Let's see. This could be a 4, this could become a 3. And what's the last thing I should do to this problem so I don't miss 1 point? Yeah, I don't want that radical in the bottom, so I'm going to multiply top and bottom by root y. So on top, I'm left with 4x to the 3rd root y. Root y times root y just gives me y for an answer. And then I had this original y in here. So 3y is 3y squared. Anything else? All right. So we got a couple things we're going to do. Huh? Sure. I'm sorry. So for today, we're going to take a 3-question mini quiz. Hey, is this mini quiz, will this hurt your grade? No. What will happen if you earn a 3 out of 3 on it? Yeah, but you have to save this and show me so I make sure I put the 3 points in. Okay? So once you're done with the mini quiz, you can start on the assignment, which will be page 147, 148, and that'll be 1 through 23 all. Friends, you'll have time this period to work on this, but please note, I will post the answers on Schoology. The third thing, we will go over the quiz. We'll go over the mini quiz. So I'll grade it real quick, get it back to you, okay? And then tomorrow we have a quiz. This one does count. Okay? Does that make sense? All right. There you go. Mini quiz coming out to you. Do well on it. Let's make sure that we feel comfortable generating perfect squares. 1 times 1, say it. 2 times 2. 3 times 3. 5 times, or 4 times 4. 5 times 5. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. 11 times 11. 12 times 12. And of course, that list goes on and on forever, okay? All right, so first thing, I'm going to take a look. Root 32. 32 is about here. So what times what gives me 32, where one of the numbers is a perfect square? 4 and 8 absolutely do work, but it's not the biggest perfect square. So that's why I start here, and I make my way up. That way you get to the first perfect square. Okay, so 16 times 2, square root of 16 is 4. So I should get an answer of 4 square root 2. Okay? Second problem, I'm going to distribute. So I get root 16 here. And I get root 4x squared y there. Does that make sense? Square root of 16 is 4. The square root of 4 is 2. The square root of x squared is x. And then I have a y at the end, root y at the end. Okay? And then number 3. Multiply top and bottom by root 3. So I get 7x root 3 on top over root 9. Root 9 is just 3 because the pair of those goes down. So that's the answer there. I saw some of you had this as an answer, which is absolutely correct. That's totally correct. Notice the x is truly outside the radical. Okay? So that right there, if you can do some of those, it's going to get you to move along pretty well on this quiz. Okay? Some of you, I think, are rushing. Some of you are trying to make it too difficult. Okay? I will tell you the very first question on the test is list the first 12 perfect squares. So you're sitting there with a calculator. I don't know what perfect squares are. What's 1 times 1? I don't know. Okay. Can't help you if you can't do 1 times 1. Okay? And just literally 2 times 2, 3 times 3. You list them out that way. You don't have to have them memorized. You just have to know how to get them. Okay? It'll help you.
Also, too, like, for example, like, number 1, when Coral brought up 8 and 4, I literally wrote on, like, my own key, 4 and 8 work, but it's not the biggest common factor. So writing little notes to yourself saying, okay, I have to, for number 1, I have to pick the biggest common.
All right. So, Coral, you did this, yes? So that technically is this. But then 8 breaks down to, and then that's going to give you 2 times 2 root 2, which then gives you the 4 root 2.
Okay.
So your way will work as long as you've broken all of the perfect squares. Don't ignore 1 because 1 times whatever, 1 works every time. But yeah, your way will work. But when we show that list of perfect squares and I put that little line, I'm going, okay, let's move up. And that way you're getting to the biggest perfect square first. Okay? If you go from the top down, a lot of students like yourself, and it's not wrong, you stop at the 4, and you're like, oh, it works. But you realize that the 4 still would have gone into it. That's why the 16 works.
Or I would also write, too, like number 2, for example, I would make sure I write this down. Can we times and root 2 to a square, x squared in the root form?
There's the answer to the quiz up there.
No. So make sure that you're writing, when you're timesing a root, make sure you're timesing a root to a root. Okay? Making sure that your root, if it has just a number in it, you're timesing that root number to a root number. Not a root number and variable, right? Just like when we add, remember, at the beginning of the year, we had whole numbers and variables. Can you add them together? No. Okay? So writing little notes to yourself like that we need to follow those steps. Use this as a study guide. Use the homework as a study guide. Okay? Use the time that you have left in